Design and construction and experimental filter for the sustainable usage of water in Tilapias farming. Engineer Nelson de Jesus López Acopa. This project seeks to develop an efficient filter that manages to minimize the environmental impact of aquaculture in the terms of water, using easily accessible and neighbor-friendly materials. The tilapia is a food wide at high nutrition level, so its consumption has been very high since ancient times. The abuse in the consumption of the species has generated desire for new ways of obtaining food, finding an auction in the aquaculture due to the characteristics in the species as its ability to adapt to the different climatic conditions. The proliferation and the development of the activity throughout the world important day by day. See, it has maintained a significant growth rate worldwide for years, which also generate other problems, so has high consumption of water for its development. This project seeks development of filters that help the activity to reduce the consumption of water that traditionally requires with environmentally friendly materials. The proposed water recirculation system for tilapia culture consists of container approximately 1 cubic meter of capacity in which the specimen will be introduced. A vertical container of approximately 0.2 cubic meters of capacity to be used as primary salter. Two containers of the same capacity to be used as filters, where the proposed materials, coconut fiber and crushed oyster shell, will be used, seeking the substitution of colonies of microorganisms for biofiltration. The culture density proposed are 33 tilapia specimens with an average age of 20 to 21 weeks and average weight of 250 grams to reach size of 500 grams, or 29 to 30 weeks of age. Since the aim is to measure the efficiency of the system in the most critical stages of tilapia culture. Low-cost materials will be collected such as coconut fiber and oyster shell, which are generally waste proposed in food and beverage marketing activities. During the development of the experimentation and implementation of the recirculation system, essential data be collected to measure the efficiency of the proposed system, such the amount of total suspended solids, pH, temperature, turbidity, dissolved oxygen, ammonia, and nutrients, in addition, and accurate monitoring of the health of the culture, carrying out sampling and statistical control that allows the deep analysis of the experiment. With the conclusion of this project, it is expected that favorable results will obtained in the experimentation that will help to reduce the environmental impact of the activity in the terms of water care being able to replicate and adapt to the different skills and development throughout the planet. It's very important to pay attention to the aquaculture due to the high volumes of water in the records, therefore offering alternatives that help in the get closer to the sustainability in the terms of the water world, being important achievement in that direction. My reference.